Our last set of probabilities is going to be working backwards, being able to identify what formula we need and move backwards. So when we're working with formulas, or when we're working backwards, we're going to substitute the information we have into the appropriate formula. Okay, it's important that it's in the appropriate formula that we actually need. And then we'll solve for the missing piece. And we solve using algebra skills, okay, using those inverse operations. Remember, we have these formulas we've been working with. Okay. The other formula that we could use is just the conditional probability. So when we work with conditionals, remember we have the probability of B given A is equal to the probability of A and B all over the probability of A. I was going to write the division sign, but that would look silly. Okay, so we could be using that too. Now, how does this relate to the formula that is uploaded on the blog, or that EOC geometry formula? Well, on the geometry formula sheet, we only have 3 formulas that we're going to use, or that we'll focus on. One of them is the conditional one, and I just rearranged my letters. The other one's the multiplication rule for independence, which is just the independent formula here. And the other one is the addition rule. So the addition rule is for mutually exclusive, okay, because if it's not overlapping, we still have that same part of that formula. So if you'll notice that these 2 formulas actually start off the same, okay? It's just if it's overlapping, we swap out that intersection. So on that formula sheet, this is the addition rule. Okay, just so you're aware, independent matches the independent. Dependent, again, follows that independent rule. Okay, we still have that multiplication factor. We just have a dependency on something given happening. Okay, and then of course I added the conditional probability there at the end. So let's look at some examples here to get us started. So the first type that we could have is a dependent example. So the probability of Sam getting an A in chemistry, let's zoom in a little bit. And autofocus, maybe it'll come in a little clear. The probability of Sam getting an A on the chemistry test is 76%. The probability of getting an A on a calculus test and on a chemistry test is almost 50%. What is the probability of him getting an A on his calculus test given he got an A on his chemistry test? So this is dependent because these 2 events, because of that word given, so that given dependency. So what happens here is we substitute the intersection, because we saw the probability of getting an A on calculus and an A in chemistry. So remember, this word "and" is the intersection of. Okay. What is the probability of him getting an A on his calculus test given that he got an A on his thing? So what I would do to note to help me identify the formula, because I feel like that's going to be the hardest part for us, is write out what you have. So they gave us the probability of, I'm going to say, chemistry, I'm going to use CH, is equal to 0.76. And then they said the probability of, I'm going to say calculus and chemistry is 0.494. And then they wanted the probability of on calculus given, so the probability of calculus given chemistry. So if those are the pieces, we're going to look at the formulas that are provided on that slide before to kind of help us through that. Okay, what pieces does this match? It matches this dependent one. So we substitute in the information that we were given. Our formula has multiplication in it, so we undo multiplication with division. So we're going to divide both sides by 0.76. So the probability of B given A, or the probability of chemistry given, or calculus given chemistry, we're going to use our calculator, say 0.494 divided by 0.76, and we get 0.65. Here, our 65% chance that's true. So let's go through this next example again. So, an optional camp to improve players' basketball skills was held in the county. The probability of a kid attending was 62%. So I'm going to say the probability of attending is 0.62. The probability that they attended and made the honor roll was 0.44. So this word "and," that's an intersection, right? So the probability of attendance and honor roll is 0.44. What is the probability that they made the honor roll? So what is the probability of honor roll? So again, using this information, we're going to match up our formulas. Well, this is an independent event. Going to camp and being on the honor roll don't depend on each other. They're two separate things. So we substitute that information into our formula. And again, we're multiplying. So we use division to solve. So the probability of B, which we said is the probability of honor roll, is 0.44 divided by 0.62. If we round to the nearest hundred, it's going to be a 71% chance. Last one here on the notes. No word problem, they just gave you all of the pieces. So again, when you have all these pieces here, we want to match up what formula is best. And we have an overlapping formula. Okay, so our union, we substituted in. We have the probability of A substituted in, the probability of B substituted in, and we want to find that intersection. So in this case, we're going to get rid of our fraction, and we're going to get rid of our fraction by multiplying by the greatest multiple here. So I'm going to, where do I want to do that? Let's do this. Let's do this a step at a time because we have this subtraction here. So I'm going to subtract 1/4. So this is going to be 2/4 is equal to 5/8 minus the probability of A intersect B. I'm going to subtract 5/8, but when I do that, that's 2/4 minus 5/8 is equal to a negative P, A intersect B. And so you could, of course, can cheat and use your calculator, but we might as well practice some fraction skills. This is the same thing as 4/8. So this is going to be a negative 1/8 is equal to a negative probability of this intersection. We can't have negative probabilities, so we're going to divide it out. So 1/8 is the probability that these two events happen at the same time, that they have an intersection of those events. Tune into the next videos for some more examples and practice before you move on into your homework. Happy studying.